Consider a single air pollutant emitting point source located on a complex terrain in a rural area. The stack has the following parameters. Pollutant emission rate is 100 gram per second. Stack height is 100 meter. Stack inside diameter is 2.5 meter. Stack gas exit velocity is 25 meter per second. Stack gas exit temperature 450 Kelvin and ambient air temperature is 293 Kelvin. So the complex terrain has consider a single air pollutant emitting point source located on a complex terrain in a rural area. The stack has the following parameter. Pollutant emission rate is 100 gram per second. Stack height is 100 meter. Stack inside diameter is 2.5 meters. Stack gas exit velocity is 25 meter per second. Stack gas exit temperature is 450 Kelvin and ambient air temperature is 293 Kelvin. If the complex terrain is 150 meter height from the stack base at 3 kilometer and 175 meter height is at 5 kilometer, 200 meter at 7 kilometer, 200 meter at 8 kilometer, 200 meter at 10 kilometer. That is, there is a plateau shape is you can see, and 10 kilometer, after 10 kilometers the terrain base height is somehow is 225 meter. Then we have to identify the final stable plume height and the distance from the stack to this final plume stable height, and next the pollutant concentration at 8 kilometer away from the stack and at 200 meter terrain height. Now we open our screen view. You can create a new project by hitting new, and you give already insert the values as per the questions, but I have already have the project, so I'm going to open the project. You can see the source type is point is selected, dispersion coefficient is rural, flagpole receptor is 0, and point source input parameters as per the questions. I have entered all the value here and then hit next. You can see when complex terrain is selected, all the other option is inactive, and the stability class is F, wind speed 2.5 meter per second, non-regulatory is no, and emitter height is 10. And this stability class is automatically selected by the screen 3. Hit next. And for this complex terrain, input all the stack base height as per the question and the distance with respect to the stack base. You can see here, and then once it is done, hit next. Automated distance is inactive, so go next. Discrete distance inactive, next. Downwash and flagpole need to do anything and hit next. When hit next, this page will appear and you see that the project is complete. You can run now, then hit run. So just this window is appear. I hit on this graph, and this is complex terrain distance versus concentration. I change these point values to line from here, this option, and okay. You can see here from 3 kilometer to 5 kilometer concentration decreases, is rate is low, but from 500 meter to 800 meter, concentration decreases rate is high, and then after 8 kilometer, you know, this is again the rate of decrease with distance, the concentration is less. So now I hit the output file and see the result. You can see here that this is our input values, and you can see that the final stable plume height is 192.9 meter, and this is 151.3 meter away from the stack base, and the concentration at 8 kilometer and the terrain height is 2 meter is 49.87 microgram per meter cube. However, the maximum concentration is found at terrain height is 150 and distance is 3 kilometer, and this is 94.10, and this is concentration is not 1 hour concentration, it is 24-hour concentration. However, the final stable plume height is 192.9. You can see from here also, because in every distance or every height of terrain, you can see the plume height above the stack base is same. So from here you can see that this is the stable plume height, and this comes first, the stability is found at 150 meter, terrain height first. So you can see that for complex terrain, EPS Screen 3 model automatically selects the following meteorological parameter. For rural dispersion coefficient, stability class is F, wind speed is 2.5 meter per second, and for urban dispersion coefficient, the stability class is E, but the wind speed is same. Above the stack is 2.5 meter. You can see the first video regarding this, but here I can give you the just basic. For E stability class, you can see this is followed, and the for F this 2.5 meter is followed. So is F is E is F is both are stable. Thank you for watching this video.